I know you're probably wondering, where in the world am I? I'm in my basement, and yes, I have a whiteboard in my basement. Don't you? Section 10.6, solving radical equations. I've written some stuff on here already because I want to be able to move through these. There are basically 4 steps to these. Isolate the radical, raise to the appropriate exponent. If it's cube rooted, you'd cube. If it's square rooted, you'd square. Solve what remains and check for extraneous solutions. Extraneous is simply a fancy way of saying an extra solution. It isn't a real solution. So isolating, you know what? This one's already isolated. So guess what I'm going to do? I'm going to square both sides because it's square rooted. And in squaring both sides, I'm going to get 3x plus 4 equals 64. I'm going to subtract 4 from both sides. I'm going to divide by 3, get x equals 20. I think that works. Let's put 20 back in here to make sure. What is 3 times 20? 60. What's 60 plus 4? 64. What's the square root of 64? That's 8, and 8 equals 8. You notice I didn't say plus or minus 8 when I square rooted, because the problem had the square root. I didn't introduce the square root. You only use plus or minus when you introduce the square root. So this checks out, so that is my solution. Let's check out example number 2. First step, isolate the radical. The radical is not by itself, so I'm going to subtract 7 from both sides. Square root of x minus 1. When I subtract 7 from both sides, 2 minus 7 is negative 5. There's your first sign of trouble. But let's continue on through. I'm going to square both sides right here. And when I square the square root, I get x minus 1. Negative 5 squared is 25. I'm going to add 1 to both sides, get x equals 26. I think 26 is my answer. Let's see. 26 minus 1 is 25. Square root of 25 is 5. 5 plus 7 is 12, not 2. This doesn't work. This is not a solution. And we can probably see that right away, because can the square root ever be something that's negative? No, no. Square roots are positive. So that's our key. Now, going back to the extraneous, what if this is a variable expression over here? You can't tell if it's positive or negative just by looking at it. So that's why you have to check these. So when we do this equation right here, we're going to have to check for extraneous solutions very carefully. Square root with a variable on the outside, that's going to be a bit of a mess. So I'm going to still follow the pattern, isolate the radical by adding x to both sides. I get x plus 2. And now I'm going to square both sides. Squaring this side gives me 6x plus 7. Squaring on this side means I'm going to have to FOIL this. X plus 2 squared is x plus 2 times x plus 2. 6x plus 7 equals x squared. 2x plus 2x is 4x. 2 times 2 is 4. My square roots are gone. Now I'm going to solve what remains. This is a quadratic. You may remember quadratic from College Algebra 1. I'm going to collect all the terms to one side, setting it equal to 0 by subtracting 6x and 7. That leaves me with x squared minus 2x plus 4 minus, that's minus 3 equals 0. Now I'm looking for two numbers that multiply to be 3 and subtract to be 2. That's 1 and 3. It's a negative 2, so it needs to be a negative 3 and a positive 1. Setting each of these equal to 0 is going to give me an x equals a negative 1 and an x equals 3. I'm not going to circle those. I'm going to see if they both work. Negative 1 back into the original. 6 times negative 1 is negative 6. Negative 6 plus 7 is 1. Square root of 1 is 1. Minus a negative 1. 1 minus a negative 1 is 1 plus 1. That's 2. Checks out. How about the 3? 6 times 3 is 18. 18 plus 7, 18 plus 25. The square root of 25 is 5. 5 minus 3 is 2. Hey, they both check out. Those are my two solutions. Okay, this example is the worst. This problem right here has 2 square roots. So when it says isolate the radical, you can't really isolate the radical because there are 2 of them. Pick one of them and isolate it. I'm going to add this radical to both sides. So I have x plus 5 equals 2 plus square root of x minus 3. I have a radical isolated. So when I square both sides, this radical will go away. This one won't, but this one will. And what you'll see is I'll end up with just one radical. Square both sides. I've got x plus 5 equals 2 plus square root of x minus 3 squared. So I've got 2 plus the square root times 2 plus the square root. That's 4 plus 2, and 2, that makes 4 of these square roots, plus this thing squared is x minus 3. So I've got x plus 5 equals 4 minus 3 is 1 plus x plus 4 square roots of x minus 3. So I kind of combined things together. Now I just have to isolate this thing. I'm going to subtract x from both sides. They cancel. I'm going to subtract 1 from both sides. I'll be left with a 4 equals 4 square roots of x minus 3. Dividing both sides by 4 to again isolate this. I get 1 equals the square root of x minus 3. This is a fairly simple process now, but all of that took me from 2 square roots down to a single square root. Let me rearrange this right here. X minus 3 square root is 1. Square both sides. X minus 3, 1 squared is 1. Add 3 to both sides, I get x equals 4. Don't circle it, check it in the original. 4 plus 5 is 9. Square root of 9 is 3. 4 minus 3 is 1. Square root of 1 is 1. Is 3 minus 1 equal to 2? You betcha. Checks out. X equals 4.